Welcome to today's KMWorld webinar, brought to you by Vertigia and Shelf. I'm Mary D. Ojala, Editor-in-Chief of KMWorld Magazine, and I will be the moderator for today's broadcast. Our presentation today is titled From Unstructured Content to Actionable Insights, Accelerating Access to Accurate, Relevant Information. Now, before we get started, I want to explain how you can be a part of this broadcast. Now, if you've attended our webinars before, you'll notice a slight change in the console this time around. To open the Ask a Question box, click on the question mark icon, which is in the center of your screen. Once there, type in your question and click on the Submit button. We will try to get to as many questions as possible, but if your question was not selected during the show, you will receive an email response within a few days. And now to introduce our speakers for today. Grant Spradlin, VP of Product, Vertigia, Jan Steheks, Director, Data and Gen AI, Shelf. And now let me pass the event to Grant Spradlin, VP of Product, Vertigia.
Thank you, Mary D. So to get started here, I think that it will be good to first just set the stage and talk a little bit about what the biggest challenges are with generative AI. The first big challenge is that the data prep, on average, takes 3 to 6 months to prepare for a single custom generative AI solution. And then on average, it takes another 3 to 6 months to deploy, to build and deploy custom generative AI infrastructure. So overall, for most custom generative AI solutions, it's taking between 6 and 12 months when you're looking at both the data prep of preparing your unstructured content for generative AI and then actually building the generative AI solution itself. And 70% of organizations haven't gone beyond experimentation. And a lot of that is because they're spending so much time on the data prep or building the infrastructure. And if they're not, then they're going to be getting subpar results. When you don't do the appropriate data prep and put that time up front, you're going to end up with inaccurate data going into the LLM, which means that ultimately you're going to get inaccurate results. So that's what I wanted to do just to set the stage, because I want to talk about why it's important, because now we'll talk about how to effectively prepare unstructured content for LLMs and RAG. And again, the main reason is we do this to prevent hallucinations. That's the term that we refer to when a model generates something that isn't the expected result. So, for example, on the left side of the screen here, we have a complex PDF, and in that PDF, there's a chart on the upper left-hand side that has the revenue and in euros, millions of euros. And if we look at what's processed on the right-hand side, so this is what the result of the latest and greatest OCR technology is doing. So, it knows that there's an image, but it doesn't know what the image is. The OCR doesn't understand the details of the image. And it does some extraction for the years 2022 and 2023, but it doesn't extract the year 2024. And then additionally, there's a complex table on the right-hand side of the PDF, and you can see how that gets converted into Markdown on the right. The LLM is not going to have a great chance of success when you ask it questions or derive insights from this PDF as knowledge, because the information that was prepared and goes into the LLM was not sufficiently prepared. But essentially, we lost information, and the LLM won't be able to find the accurate result. And that's what leads to things like hallucinations. So at Vertigia, what we do is we have a way to add a semantic layer on top of the content. So what we do is we transform the PDFs into a structured XML, and we intelligently process each page, because some pages might be very text heavy, other pages might be image heavy, but we can detect what's in the page and what's in different zones of the page. And when we do that, we understand how to best augment the original content. So we're never going to rewrite or modify any of the original content, but we'll pull out the information that's in tables. will appropriately identify what's in images, and will preserve the full content hierarchy so that we don't have, we have the original fidelity of the source document. So you can see on the right-hand side, again, we have that same complex PDF, and we have the chart that has the years and the revenue. And we can see that the corresponding XML captures the actual revenue value tied to the specific year. So we didn't have any information loss. Likewise, for that complex table, we have an identifier for each column with for each row with the value from the column. So this is the type of information that you need when you are preparing text for LLMs. But that's just one step. It's actually a bit more complex than that. So when you're going to prepare content, not just for LLMs, but for RAG, for retrieval augmented generation, essentially what you need to do is you need to do many more steps. So like I showed you in the previous slide, the first step is you need to prepare the text. So that's where we can either extract the text or we can prepare the text with this semantic layer to better articulate what's in complex documents. But you also need to do things like classify the content. And you need to identify schemas and properties to provide metadata for this content. And you also need to then generate the metadata for the content. And this is going to ultimately help drive the searchability and the findability of that unstructured content. But a lot of times, one piece of content is too big. And if you use that in your prompts, then there's extra noise that you don't want that, again, can contribute to hallucinations because you're not giving LLM the more precise content with the right focus. So when we chunk content, we're breaking down these unstructured documents into smaller parts without losing the meaning. We preserve the semantic meaning of the original source content. And then we're also going to create embeddings for things like the full text, the properties that we generate, and also the images. And the reason why we do all of these things is they all become different tools in the tool belt to drive the search or the retrieval. So you can retrieve based on full text. You can retrieve based on structured search of the metadata. You can retrieve just specific chunks. You can do vector search against your embeddings or even a graph search. And all of these are just different search tools. They ultimately augment your prompt and do a final generation with the LLM. So this is just a very quick and high level overview of the complexity and the amount of work that goes into preparing content to avoid things like hallucinations. So next, I will move on, and I want to talk a little bit about the techniques to interrogate knowledge using generative AI and natural language. So the first technique that I'll talk about here is producing structured insights. So you might have a piece of knowledge that determines what makes something compliant or not. So this first piece on the left, we have a compliance check, and we're using that knowledge to determine which applications are compliant and ready to be processed. And so this list here is identifying a number of items that are not compliant and why it's not compliant. Next, we can generate properties around the key business information. This is always unique and tailored to our clients. So it's our client specific taxonomy in ontology. It's what makes this content interesting and what information we want to generate to support the search, the retrieval, and just the general access to the knowledge. What information do we want to know about these documents? And then the third type of structured insight that we have here is that you might have knowledge around guidelines, standard operating procedures, rubrics. So let's say you have a rubric on how to review and score a document. So here we have a proposal, and we have a rubric about how to score that proposal. And here we're generating scores using generative AI, and we're identifying the positives, the issues with the proposal, and also comments. So here we actually have one comment in particular that's about one of the positives. So this had a score of 2. The score, according to this rubric, that score is very, very good. Perfect score is 1. And it's pointing out that there's a novel approach to studying belief-related bias rather than just unblinding. I know maybe that's not super clear in the slide, but that's what the positive says. And as a human reviewer, as a knowledge worker, as a business owner, I want to understand that AI generated information better. So what we can also do is we can also use another technique to have a better human understanding and perform human analysis on any collection of content. And we can chat with that content using natural language to get domain-specific answers. And while we do that, we can enforce the business guardrails to make sure that we're only answering questions about a specific collection of content. So in this example, let's say it's that proposal from the previous page, it's the guideline for the scoring rubric, and then maybe it's also the actual AI insight itself. So we can pick any collection of knowledge or content and interact with it in real time via chat. And then over on the right, you can see that we can even interrogate the AI insight. So the AI said, hey, you got a score of 2 for innovation, but I want to know as the human reviewer why that score was so highly rated on the innovation metric. And I want to cite directly from the source what the innovation was and on what page number. So I can ask the LLM, any questions about the document or the AI insight and get those answers very, very quickly in real time. And then the last technique that I'll talk about here are agentic insights. So in the Vertigia platform, you configure agents using our low-code tools, and then you provide those agents with some collection of content, whatever we want, whatever knowledge we want that agent to have, right? It doesn't have access to all knowledge in the enterprise. It's just the knowledge that that agent needs to do its tasks. And we can expose these agents in common communication tools like Slack, and again, interact with that agent in natural language to autonomously interrogate content and still enforcing those business guardrails. So what you can see on the right here is starting a Vertigia agent that verifies employment contracts, and it's going to think about what that task means. It's going to use tools like searching documents and fetching documents in order to analyze what information it has access to be able to answer the questions and the tasks that it has at hand, and ultimately form a plan, and then execute that plan to provide the answer. And that's what we're seeing on the screenshot all the way on the right in the slide, is it creating the plan and ultimately providing the answer. And so we have the full trail of all of the thought process and all of the actions that the agent takes, where and meeting the users where they are. In this case, they're working in Slack. They could be working in another application. But that's just an example of agentic insights to take it a step further from the structured insights and also the human interrogation. Although I should mention, even with the agentic insights, while we're in that chat, we can ask follow-up questions and further interrogate any information that's provided by the agent. So for more information, you want to understand a little bit more, you want to check out the Vertigia platform, our agents, please visit vertigiahq.com. And with that, I will pass the ball over to Jan.
Awesome. Thank you so much. This was very insightful. My name is Jan. As already Mary D introduced me. You keep on impressing me with your last name pronunciation capabilities. I'll definitely refer a few of my coworkers. So I'm Jan, Director of Data and Generative AI at Shelf. Shelf, we're all about unstructured data, unstructured content, managing it, organizing it, quality assuring it, and preparing it for Gen AI consumption. So what I want to share more about today is what we're seeing in this space, what we're recognizing as some of the key issues with unstructured data, and how the Shelf platform is helping organizations tackle some of those issues. So first, and Grant already shared a little bit about this, which is the role of unstructured data is now different than it was, let's say, 5 or 10 years ago. And it's become a hot topic because of generative AI. With the emergence of generative AI changes many, many things. And one of those things is how we utilize data. And it puts unstructured data on center stage. Why? It's trained on vast amounts of unstructured data that has been labeled. And second, and this is especially key, is in enterprise Gen AI use cases, we require large language models to interact with organizations' unstructured data. And then this leads to some of the issues that I'll talk about in just a minute. And then traditionally, this data, unstructured data, was not actively managed or quality assured, and it was not created with the purpose of it feeding or fueling a downstream generative AI solution, like a chatbot or like a RAG solution that Grant spoke about. And on top of this, the majority of enterprise data is unstructured. So here's one data point: 90% of all data is unstructured data. And again, this is the data source that was not primarily managed or was not, let's say, a focus point. So let's say structured data was that let's say popular kid on the block. And now looking at unstructured data, all of a sudden we're using it in these high priority use cases. It's not leading to good outcomes. Garbage in and garbage out is very much true with generative AI. We need to do something about it. And following structured data patterns is not something that works with unstructured data. So it's a different beast altogether. And again, I'll share a little bit more about that. What I also want to share a little bit more about is a survey that we did just a few weeks ago, and it was on the topic of Gen AI, the state of enterprise Gen AI, and unstructured data. So what we explored is how are people using unstructured data, again, in the context of generative AI use case. And one of the questions we asked is, to what degree are unstructured data issues impacting the success of your generative AI initiatives? And what we found here is, so here, for instance, the top answer was moderate impact at 40%, and then the second one was some impact, and the third one was large impact. But ultimately, what the survey found is that 92% of respondents reported unstructured data issues, again, in the context of Gen AI initiatives. And then 70%, so that's more than 2/3 of all respondents, think that the impact of unstructured data is material or greater. So this makes this a high priority issue to address, especially with generative AI now becoming, let's say, I think for the majority of viewers, I'm sure one of the top priorities for 2025. And then the logical next question is, what is required to prepare unstructured data for AI? And what different surveys are finding, what different researchers are finding, is data quality is that number one blocker preventing Gen AI success. So again, multiple analyst firms, multiple surveys done, they all point in this direction. Data quality is something that you need to think about when you're looking to deploy generative AI solutions. So I might as well change this line or sentence on the screen to what's required to prepare for AI. It's handle unstructured data quality. And we did explore this further, and I'll share a few more answers or questions from the survey that what we were interested in is just understanding this problem deeply. So one of the questions we asked is, in what percentage of your unstructured data do you think there is at least one issue? And I'll invite the viewers to also kind of think about the state of unstructured data in their organization. And when thinking about unstructured data, I think it's also good that we think about what is it, right? What are some of those data sources that we're now using? And that was also one of the questions in their survey. And the top answers there were PDFs, Word docs, Google Docs, things like that. Product documentation, different policies, HR documentation. Those are now the documents that we want used in downstream Gen AI applications, such as RAG in employee-facing productivity tools or customer-facing support bots. All of those are, let's say, drawing information and knowledge out of unstructured data sources. So these were the answers in our survey. And as a key takeaway with this one is 67%, so 2/3 reported quality issues in over half their files. So with all of these findings, is almost as if we are adding if we're adding fuel to the fire. With so unstructured data is now that primary fuel for generative AI. It's 90%. It takes up 90% of all data that we have in enterprises, and there's issues in over half those files. And this is something, again, that makes this a high priority fix for organizations. And here, let's say 67% reported issues in over half their files. At Shelf, from processing millions and millions of documents across different industries, these are the actual numbers we're seeing. from processing content from different industries. So over 90% of files, documents and files contain at least one inaccuracy. So again, think about your presentations, think about your documents and files, PDFs, Google Docs. 26% of respondents, these are actual numbers. 26% of files contain outdated information. 33% of files contain duplicate and redundant information. And then lastly, 12% of company files have at least one compliance issue. And these are especially concerning thinking about protecting your data assets and similar. And for a lot of organizations, the strategy in let's say 2023, 2024 with generative AI is let's just hope it works. We have these magical new technology that's doing wonders. Let's just feed it this information, hope it works. And strategy is not or hope is not a strategy, and this is not something that worked. This is why the numbers of failed projects were also very, very high. Again, to some reports, over 80 and 90% of Gen AI projects got halted or failed altogether. So getting back to the question, what is required to get unstructured data ready for AI? One of the questions we also asked is, if you had a magic wand and could have a tool that would help you with your unstructured data tomorrow, what features would you want it to have? And here the top three answers were: 52% ability to identify inaccurate information, 42% ability to identify conflicts or conflicting information, 33% ability to identify missing content, so content gaps. So those are, let's say, the top three capabilities that are needed to get unstructured data ready, to get unstructured data quality assured for generative AI. And I'll just share a few examples what these actually mean. Imagine with inaccuracies, imagine you have an outdated document. No matter how good the large language model that you're using downstream, if that document that it's using to answer a question is outdated, it will provide an outdated answer. And with the second one, ability to identify conflicts, if you have an outdated, or let's say if you have two versions of a product catalog that both mention a different product price for the same product, again, no matter which large language model you're using downstream, it can be the state-of-the-art model available, the most expensive model available, it's not going to provide a good answer. And then again, very similarly with missing data or missing content. If there is no answer that the user is looking for in the data, no LLM will provide that answer. And these are exactly the capabilities that we're working on at Shelf, or that we have built into our platform. And the platform is designed to help companies automatically identify, fix, and monitor unstructured data issues so that you can deploy generative AI with confidence today, so that you can combat that garbage in, garbage out problem. And the Shelf platform, it acts as a quality assurance layer that sits on top of your data, and it shows or highlights all the problematic areas that exist in that data. It's going to highlight the document that is highly likely to be outdated. It's going to highlight document sections that are conflicting, that are causing issues downstream, and it's going to do that through time or continuously, so that you constantly have that dashboard available to you, so that you can see where those issues exist and what issues are being caused downstream because inaccurate data is fed directly to generative AI solutions. So to quickly summarize, unstructured data is now that highest priority. It's what's fueling generative AI downstream, and the capabilities that are needed and the capabilities that are also present within the Shelf platform are the ability to eliminate bad data before it becomes bad generative AI answers, before it becomes bad AI agent actions, which is now something that is also becoming very popular. Second, gaining control over unstructured data. So we saw 90% of all enterprise data is unstructured. That means volumes of information. You need a way to control that vast amount of information, and you need to be able to identify issues, even though they are very hard to find, or let's say almost impossible to find manually. Third, you need the ability to continuously improve the quality of your generative AI answers, and the top issue with those is, again, garbage in, garbage out, poor data quality. And then lastly, getting answer transparency for responsible AI. You need to be able to monitor what is the quality of insights or answers that are being generated based on this unstructured data. And having this understanding gives you that closed loop, or that loop of continuous improvements, so that you can see exactly what is the downstream impact, and then you can see exactly where the issues exist at source, and that source is unstructured data. And so for more information, I invite you to visit shelf.io, and we'll be happy to give you a demo deep dive, so you can understand better how exactly the Shelf platform works. But essentially, it connects to any or all common enterprise content repositories, and immediately as it processes that data, it's going to highlight all issues that exist, all issues that would otherwise lead to inaccurate downstream generative AI answers. Thank you, and back to you, Mary D.
Great. Well, thank you, Grant, and thank you, Jan. So now I'd like to move into some discussion with the two of you. I'm so interested in the pre-processing aspects, or as Jan was saying, preparing the unstructured data for AI. So I'm really curious to delve into this just a little bit deeper and see how do you improve the accuracy of the AI generated insights? How do you reduce potential biases? And really, we're talking about how unstructured data can turn into actionable insights. So how do organizations actually ensure that the insights are truly actionable? Let me start with Grant.
Sure. So I think to the first point, and the accuracy of the insights in what we're doing here, right? You really need to preserve the original content, like I was talking about in the presentation, and layer on top of it. What most people are doing today is just a basic text extraction, and in that case, you lose the complexity in the hierarchy of the content. Essentially, you're flattening it, and then also, when the other approach, rather than just extracting text, is to try to do some type of OCR. When you do OCR, you're picking and choosing what information you extract. And again, you're losing the original meaning of the content as it was meant to be, presented by the author or the content creator. So I think the first thing is preserving the original content. And then the second thing is being able to prepare the content so that you can use it with accuracy and with focus. So again, if you give an LLM a big piece of content, and you give it a few pages, but there's only one paragraph in there that's relevant to what it needs to know to provide an answer, you're just giving it noise. So being able to Jan's point, you need accurate content, you need correct content. It's a really important fact, because it's going to be garbage in, garbage out.
Right.
In terms of the insights and the accuracy of the insights, that's where you can really lean on generative AI. You can use generative AI to provide justifications, to provide explanations, to provide the action for that insight, and then also, like I explained in my overview, that you can there's different techniques for people to interrogate this content and to come to their own conclusions and to come to their own actions. So whether it's structured or it's ad hoc by the people operators, they're both good ways to get there, but they're both techniques that can be used together to really interrogate and get the answers that you're looking for.
Jan?
Yeah. So I think pre-processing is a crucial step, and that quality assuring whatever is getting fed into downstream generative AI. That's a very important and crucial step of the full pipeline. I'll steal a line from one of my colleagues, which is generative AI makes bad worse and good better, right? So that the quality of that input going in is really, really crucial. And if you're gonna be using outdated information, poorly structured information, improperly extracted information, conflicting information, all of this is gonna decrease the quality of Gen AI generated answers. And this goes also for biased information. So the way we're approaching this at Shelf is we we are looking to provide a comprehensive analysis of the quality of the data that is being used in generative AI, meaning different diagnostics that assess the quality from different perspectives, right? And those identify and flag those issues. They flag bias or toxic information. They flag outdated information. They flag conflicting information. And this gives users the understanding of what is the quality of data that they have, what is the quality of the data available, and then they can make sure by either setting up filters or by cleaning that data at source to make sure that, again, whatever is shared with generative AI is trusted, is accurate, was verified by a human. So the human in the loop is also something that is very important. And through this, we can directly impact the quality of Gen AI, of Gen AI answers.
Yeah, I was actually amazed, Jan, at that number in your survey that 94% reported one major inaccuracy. That's an extraordinarily high number.
Yeah, it is. It is. And that number is actually not from the survey, but from the actual data that we analyzed, right? So it's
why that number is so
high. Yeah, it's a huge number. And why that number is so high is also, or one of the reasons is that data was not actively managed. And generative AI is introducing new requirements. Because this data was not, that PDF that you had was not, that someone put together a few years ago was not designed for Gen AI consumption. And now you need to take steps to make it ready for generative AI, and not taking those steps. And a lot of those steps Grant also outlined in his presentation. Not taking those steps is what leads to that number being so high, right? So let's say raw data fed in, a lot of that data is just not going to be fit for purpose.
Yeah. Yeah. So when you confront these issues with data cleansing and so on, what do you think are the most potent challenges that organizations are facing when they're trying to clean and pre-process such a large volumes of unstructured data? And how do they overcome all those hurdles? Grant?
Yeah, when you get to the question of volume, I think you need to treat it like any content-centric project, right? You got to start with some smaller batches before you process the large volume of content. But as you get to the larger volumes, this is really where the content classification is really important, along with the data prep, because you're going to have different types of content with different processing requirements that you're going to use in different ways. So if you have this large volume of content and you're just going to migrate the whole thing, right, you're going to have to take a lot of nuanced steps for the different types of content in there, unless you have an entire RAG pipeline. In the case of Vertigio, we have a RAG pipeline out of the box, so it's very easy to do this. But when you're building it from scratch, there's a lot of things to think of and consider for all of the nuances and kind of different ways that the content could be used, and the fact that you're processing likely a large variety of content.
Jan?
Yeah. So the volume is definitely the first hurdle, because identifying those issues manually is close to impossible, right? Like, imagine you have organizations have millions of documents and files that they now want to use in a downstream application, such as, let's say, a chatbot. So someone going through that manually, that's a close to impossible task. So here, tooling is definitely necessary. And one good thing is that generative AI and the capabilities of large language models can actually help identify some of those issues. And what generative AI is very good at is processing large volumes of data. So this is something that we use to great effect at Shelf, and within the Shelf platform, a lot of our data quality algorithms are Gen AI enabled, so that we're able to extract some of those quality insights using large language models, and then to build on what Grant said is classification and segmentation of content, so that you can start organizing that into these smaller batches, which are easier to understand, easier for humans to understand. Okay, so this is, let's say, I don't know, marketing department content. This is financials, and so on and so forth. You need to take those steps to segment this content. What we frequently see is kind of that first step was let's just feed everything downstream and kind of hope it works. It's that work that is needed upstream to decide, okay, what is actually the data that we need within this use case, and then deciding what are the quality metrics that we want to understand better, what are some of the risks that exist within that data. Again, all of that is going to depend on the context of the use case downstream. But I think those are the challenges, and those are some ways to address those.
Yeah, it's interesting, Jan, to think about metadata. So, I mean, you touched on this, but I'd like to go into it a little bit more in depth. What role does the metadata play? How does enrichment come into this? And because of course it's all about, you've got all this information, but it's valueless unless you can actually get to the heart of what you want to know.
Yeah, exactly. I think metadata is extremely important, especially alongside unstructured data. Right? Think of a raw PDF or a raw document that you want to use without additional context around. It's very hard to use. And I'll also borrow some of Grant's lines. Right? He was explaining how you chunk the information into these smaller bits, and that ends up to loss of context. Right? Where is that coming from? It's almost as if you're ripping. If you're taking a book, you rip out a page and you give that page to someone, and now you're asking questions about that page. I have no idea where this is coming from. It's not much different with generative AI and large language models, right? You feed it that chunk of information from your document, and you expect it to understand. It's not what happens. So what metadata allows us to do is provide that context, and what enrichment allows us to inject business context around our unstructured data. This means, let's say, a description of a document. What was that document created for? What issue is it addressing? What was it designed? Who is supposed to read that document? All that is extremely valuable. And then things like company-specific terminology that is frequently used within those documents. Without additional context around those, again, it's going to be very tough for large language models to process that data. So the way we're looking at metadata itself is enriching information that exists within the documents, and I think metadata is the path to making those documents and that information fit for purpose.
Grant, what role does metadata play for Vertigia?
Yeah, it's very very similar, and it's really not surprising, because even outside of generative AI, the role of metadata is to help people find it. And the reality is you still need metadata to help people find it, and you need metadata to help AI find it too, right? So it's all about the the searchability and the findability of your content.
Yep.
And the more that you can decorate it with additional metadata to help make it findable by users and or AI, because you want to again provide multiple ways to provide the information, right? So people a lot of times when they talk about generative AI, they talk about a similarity search, right? They talk about embeddings. And a similarity search is great when you want to find similar text, like around a full text. But if you want to go, fetch a contract by ID, you're not going to do a similarity search on ID. You're going to want the exact property to fetch the ID based on the property. So there are times where you want that structured information to do a structured search. And other times where that structured information can still be used to provide additional information around the unstructured content, and also just downstream systems, right? We still have systems downstream that need to, based on content value X on document, I need to route one way versus another way. So those things, until all systems go away and AI just understands everything, we still need the metadata for traditional practices as well.
Yeah, the nuances of search have been around for a long time, and I think it's not just the nature of the subject of the search, as you're saying, but isn't it also who's asking and how does their brain process what they want to know, because they're going to phrase it differently. And does metadata help with that?
It can. So again, if you're doing an exact keyword match, it's not going to help because you're not going to match the keyword. But assuming that we're using different phrasing, we're likely talking about a similarity search, right? We're using natural language to do the search. In that case, you can do a similarity search on properties, and again, find properties not using the exact keyword, or rather find the documents but according to the properties, even though you didn't use that exact keyword, right? The property is car, but I searched and I said trucks or vehicles or some other synonym that means that in human language, means the same thing.
Yeah. Jan?
Yeah, definitely. Just capturing the intent and also knowing what that person is more likely to be interested in are all, let's say, dimensions around that query that need to be taken in account. And this is where metadata around the original content can help us do this matching, right? Exactly what I was mentioning earlier. Let's say for each document, we do have some additional information about who this document was designed for, who it was supposed to be accessed by. This can all go into matching based on who is querying the system. And this is something that can greatly help with search, which is extremely relevant with unstructured data where you have volumes and volumes of information. So that making sure that retrieval part of it is doing its job well, it's equally as important as what is actually what is also then fed into the downstream bot for question answering.
Do you think the whole emphasis on generative AI in today's world and natural language querying, which I think you've both mentioned at some point or another, how does that change the roles and skills that are needed within teams in organizations? One of you want to?
Yeah, I can go first. I can go first. So okay. I think it plays a huge role, and I think it's extremely important. And this is something. One of the capabilities within the Shelf platform is also the Search Copilot. It's a conversational AI assistant that helps you get to the right documents. It helps you, or it will answer questions based on your documents. And what we see very frequently as one of the first steps there is just making people familiar with prompting best practices and how you should ask a question. And where there's sometimes an issue is, let's say Googling is a skill, right? Some people are very good at Googling. They know what to put into to find the right things. And then some people not so much. But querying a Gen AI system or a RAG system is not the same as Googling. And this is maybe what we sometimes do see. People approach it with kind of that similar, keyword search as opposed to really providing a context-rich question. So this is kind of one of the best practices that we share. Provide as much context as possible what you want that bot to find, because it's going to be able to take those things and those things are directly going to enrich the vector that is generated for that query, and then matching it to the content. And this is what Grant was explaining earlier with the embeddings. Matching is just that much easier and that more powerful if you do provide that additional context, as opposed to just saying, putting those 3 words in and hoping it works because we're perhaps used to it from Google. But definitely prompting is a skill. It's one of the things that employees need to be trained on, or let's say best practices need to be shared so that they can really get the most out of such solutions.
Do you find that people will actually sit still for something called training in prompt engineering?
Hopefully they should. They definitely should, because it's gonna make their job a whole lot easier and they'll be a whole lot more efficient. But I see your point.
I mean, it seems like with your example of Google, everybody just went to Google and it was trial and error and they figured out how to do it. Prompt engineering, I think, is a little more complicated, complex. It takes a little more behind the scenes thought process to come up with good prompts.
I agree. But then experimentation is still going to be very valuable, right? And as these tools are in use more, I think people are going to get more familiar by it, and it's going to be second nature eventually. But at this point in time, I think it's very important to go through a training and just to have a better understanding of what happens under the hood at a high level, obviously, so that you can know what you're actually doing with your questions.
Yeah. Grant?
Yeah. I mean, I completely agree with what Jan said here. We've seen the same where people struggle with writing prompts. So I think one aspect is that natural language search it will make the search easier for the common user, right? Because they can use their own language. They don't need to be trained as specifically, but that doesn't mean that they're going to get the best result when they search if they don't know how to search. To Jan's point, and when you get into needing to write a prompt, that's where certainly we've seen a lot higher barrier because people aren't familiar with writing prompts like they are Googling. And so one of the techniques that we've been using is that, one of the best systems to write prompts are the LLMs themselves. So
Yes.
using chat-based interfaces to take the conversation and convert it into a prompt, right? So let's chat and understand about what it is I'm looking for, and then from that generate the prompt that's needed. Having more tools and creating kind of more interim steps will be really helpful. That's where I think we'll see a lot of the ways that people interact with these systems is going to change. That's the main thing.
Yeah. And I guess they learn as that change occurs.
So it goes.
We hope, right. So being the editor of KMWorld magazine, I'm always sort of interested in how all of this fits into knowledge management. So Grant, what would a future-ready KM system look like if AI is at the core?
Great question. We talked about the need to prepare knowledge. Like you can't always just take a single knowledge document. Sometimes you have to break it down and enrich it and all those types of things. So that's one aspect. We've already talked about that quite a bit. But so that's certainly one aspect of an AI system. AI being in a knowledge management system. The other aspect is generating new knowledge, right? As Jan said, and I like now I'm going to steal this one from you, right? Knowledge is the fuel for LLMs, and it couldn't be more true. So one of the things that we're seeing is that as people get relieved of like the repetitive, mundane manual tasks, right? One thing that they can do is they can focus on higher value tasks. But the other thing that they're doing is focusing more on creating new knowledge for the AI, right? Because unless you have that knowledge, documented, you can't use it with AI, right? That process can't be effectively AI enabled. So we see a lot more effort being put on creating knowledge as well, and I think that's one thing that AI will help do in these systems.
So creating knowledge, that's really interesting. Yeah, Jan. You want to weigh in on that?
I think it's going to impact all aspects of knowledge management, right? Knowledge creation, quality assurance, management organization, all of that. I think there's, especially with these new agentic capabilities that are coming up, AI agents, there's definitely, this is something that we're also working on at Shelf, is AI agents that's going to help us quality assure data, that can help us find issues within content, that can help us create better content. All of that is going to be impacted, and it's going to make some of those repetitive tasks automated, and then it's going to allow humans to focus on those high value adding tasks, creative tasks. And I think a lot of those, as Grant said, have to do with new knowledge creation. And this is, I think, where the focus is going to be for humans. But I think this is an area that will be greatly impacted. And it's also the area that will play a crucial importance within the broader organization, which is looking to adopt generative AI. I think knowledge management and data management and structured data management is something that is going to play a huge role in again, the general adoption of generative AI within the enterprise.
It amazes me how quickly we move to agentic AI from Gen AI. It's mind-blowing sometimes about how quickly these technologies move forward. I'm assuming they're moving forward. I'm hoping they're moving forward. Well, let me shift gears a little bit here now and go to some questions from our viewers. We do have one here. Who, in your opinion, should be responsible for data quality? Grant.
Yeah, so I think there's a big blurry line between traditional data quality and preparing content for generative AI. So of course you need to have data quality, but a lot of times when we're talking about data quality, we're talking about the quality of structured data. You can certainly have data quality around unstructured data as well. But I think when most people think about data quality, they think about the data quality for structured data. So I guess this is a long-winded way of saying it's really the responsibility of who owns the generative AI solution, right? That's using the content. That's who ultimately is the owner. I think, thinking that there's going to be a centralized group that prepares all content for all generative AI use cases. And there's no omnibus. We got to fix the data quality, and then it can instantly be prepared or used for any and all generative AI. So it's still tied a lot to use case and how you want to use the content. What is the content? So I think for now, what we're seeing is that it's the business owners, the project owners, the people that have the scope of the solution, that own the scope of the solution.
So what you're seeing is multiple owners within an organization.
Yes. Yep.
Jan?
Yeah. So I think data quality is a cross-functional effort. So like Grant said, you need people who have that understanding of the downstream impact and own the quality of let's say generative AI enabled solutions, or let's say Gen AI generated answers, right? People who own that, and people who are responsible for delivering high quality answers. Those people need to be involved in the process, and then you also need to involve the people who have the subject matter expertise to say that something is that something is off, or to determine what are some of the quality metrics that we will follow. Let's say someone who can say, let's take a practical example to say, hey, this is no longer updated. This is no longer a relevant document because we created a new one. So you need someone who has that knowledge. And that is frequently not the same person as let's say, someone who's developing solutions, Gen AI solutions. So we see it as a cross-functional effort. We see it that this is something that is evolving quickly, because it's now, let's say, a new requirement. Hey, we're using these documents in generative AI. We need to do something about them because there's issues in there. So I think it's something that organizations are figuring out. But at the end, I think it's definitely something that's going to take a cross-functional effort to make it work. And it's an absolutely necessary effort to make if you're gonna. Some people unfortunately ignore it or ignored it in the let's say last 2 years. And kind of,
Really?
got burned as
How
a
can they ignore it?
consequence.
I'm sorry. You lost me there. How could they possibly ignore this?
Yeah. Unfortunately, they did. They made a decision that, generative AI is this magical new thing that doesn't really care about what you give it. Is gonna generate gold, whatever you put in it. That's unfortunately not the case. So it's now kind of coming around. Hey, we need to do something about this. We need to have a scalable way of addressing this. And this is where this effort is then required.
We're back to you waving the magic wand, I suppose.
Yeah, that's right.
I want one of those.
Yeah.
We've been talking this whole hour, we've been talking about unstructured data. And we have a question here about, let's back up to basics here. What is our definition of unstructured? And do you see such a thing as semi-structured data? That's a new one for me. So what, Grant?
Yeah, I can take that one. Sure.
Semi-structured.
Yeah. So we come from the content management world. We're content management experts. We've seen all, structured, unstructured, semi-structured. So I kind of put semi-structured in the same bucket as unstructured, meaning that it's not totally structured. So you generally need to, like, if it's not completely structured and perfectly organized, then essentially you need to treat it down the unstructured path, right? Even though it has some structure. Yeah. So it might have a sidecar with some metadata that you can leverage, and you don't need to generate. You can use that in the process. You can use that in decision making, or inside the document there might be a repeatable template. Like maybe the unstructured content actually came from a template, so it's fairly templatized. So in those cases, we treat the semi-structured just like the unstructured. But absolutely, semi-structured is fair game, and it's out there. I think, like, when you take Jan's stat about 90% of the content out there being unstructured, I think it's 90% is unstructured or semi-structured. It's just only 10% is structured.
Yeah, that kind of correlates with what I've seen. Yeah, Jan?
Yeah, I agree with I agree with Grant here, and we've had discussions in the past with people who are really passionate about this. So, what do you mean with when unstructured? This is some semi-structured. So, I think in reality, it's a spectrum. It's not, there's no these, hard lines between, hey, this is structured. Oh, now you're in the semi-structured realm because you have something there. So I agree with Grant. I think we're talking about structured data that fits easily into databases, into relational databases. And then you have unstructured, where we're talking about text, where you have documents, files, presentations, videos, things like that, sound recordings. This is where we get into the unstructured realm. And this is what this is where the kind of vast volumes are compared to structure. But I think there's different definitions out there.
Yeah. I will say that in the very early days of search, when everything was structured, it was a lot easier. You didn't get as many good answers, but it was easier. You could say, yes, there's a structure here. So this is sort of an oddball question, but I thought I'd run it past you guys anyway. Ideally, what percentage of content should be human curated versus machine curated? We always talk about human in the loop, but that's usually a fairly small percentage, isn't it? Jan?
Yeah, I think it's the answer is going to depend on the use case, right? How are you looking to use that content? Where is that being generated? That's gonna, if you have something that is, let's say high risk scenario, then this is where you would want a high percentage of human in the loop, or just fully human created. And then if you're dealing something which is more at scale, but perhaps a lower risk score, then you're looking at a higher machine curation. But I think in the future, what we're going to see is this machine curation is going to go up, and as you said already, it's going to be that human in the loop process where the autonomous solutions are going to handle most of it, but are then just going to ping humans, hey, I need your intervention here, I need your input here, or I need you to check. Sure. So I think this is where the future is, but it's going to depend on the use case.
Grant?
Yeah, I don't know that there's a magic percentage right now. And I think in many cases, when content's being created, people are doing both now simultaneously. Maybe generate some text, but then they still manually edit it, or they manually write text and then they use the LLM, the AI model to change the style or check it for errors or rephrase things. Similarly, with if you're going to generate images, you might use AI to generate inspiration, but then you might take that inspiration and, an artist is still creating the final image with the layers and, doing the finishing touches. So I think at least for now, it's not necessarily a hard split. And I don't know that there's a hard and fast rule, but they're both, they're both still out there and they both have values. And I very much see them playing together for some time.
When we talk about unstructured data, your mention of images just made me wonder, are we considering images as unstructured data, and will that grow? Will that become a more important part of organizationally stored data?
Yes.
Because it hasn't been really up till quite recently.
Yeah, maybe less in the knowledge management space. But certainly, what we've seen, again, we come from a content management background, and what we've seen as over the last 10 years is even people that were traditionally processing just text-based documents, it's just rich media is out there. They have audio, they have video, they have images, and it seems like that is only growing. So that might not be the primary knowledge document, because honestly, knowledge is best as text. But there might be some forms of knowledge, where, it's just not captured that way.
Yeah.
And certainly when, outside the knowledge management system, when you're working with generative AI, absolutely, you're dealing with, all of those other forms of rich media as well.
Yeah. Jan?
Yep, could be. I think, again, it's going to depend a little bit on the domain, right? In certain domains, I think you could have a lot of images capture a lot of rich information, which is especially good for humans. It is something that, AI is not or let's say you need a specialized Gen AI model that can process images well, and then especially if it's a image that has a lot of detailed information, because text was, let's say, that primary training data source for large language models, and then images were kind of an extension of that. So I'd be interesting to see. I'm not sure about the future, if this is something that will we'll just kind of make a decision. Hey, this should be stored as an image. It's not something perhaps that we're seeing, but I think there could be domains where that is something that will be, let's say, a trend.
Yeah, could be a trend. Could be the future. Watch this space. Well, that is all the time we have for questions today, and we apologize that we were unable to get to all of your questions. But as I stated earlier, all of those questions will be answered via email. And I would like to thank our speakers today, Grant Spradlin, VP of Product Vertigia, Jan Stilich, Director, Data and Gen AI, Shelf. And if you would like to review this event or send it to a colleague, please use the same URL that you used for today's event. It will be archived for 90 days. Plus, you will receive an email with the URL to view the webinar once the archive is posted. If you would like a PDF of the deck, go to the handout section once the archive is live. And thank you again for joining us.